Exponential, doing its thing.
Hey guys, in case you missed last class about the exponential tables or you're having trouble with the bell ringer, this video is for you. As a reminder, your exponential functions are in the form a times b to the x. A represents the y-intercept. You can also think of that as your starting point. And then b is going to be known as the rate of either growth or decay. All right, so we're asked to complete this table. We have a function. You're more than welcome to use the calculator to evaluate the y values, or we can just kind of think about this for a second. We know that anything to the 0 power is 1. So 4 to the 0 power, we can already put 1. So we already have a y-intercept because we see the point where x is 0. So you can come on down here and already answer one of the questions. Your y-intercept is the point 0, 1. All right, well, with the other values, anything to the first power is itself. So this would be 4 to the first power, which is 4. Okay, if x is 2, our answer is going to be 4 to the second power, which is 4 times 4, or 16. All right, and then we'd continue. 4 to the third, 64. And of course, you can use your calculator to help if you're having trouble. All right, so you'll notice as we're going up, we're multiplying by 4 over and over. All right, so then if we are going to fill in the table backwards, we're going to want to divide by 4 over and over. So 1 divided by 4, 1/4. Divide by 4 again, 1/16. 164. So it looks very similar to your numbers down here, except that now they're in the denominator. They're getting smaller and smaller. So as the x values increase, the y values are increasing. Therefore, this shows growth. The b value, okay, your rate of growth is going to be that number that you're multiplying by over and over to get to the next value. So the b value here is 4. All right, now let's take a look at these fractions over here. They are getting smaller and smaller. Okay, eventually you could reach like 1 over 300 million billion. That's not a real number, but you get the idea. The problem is, since there's always a 1 in the top, this will never equal 0. So our exponential functions are going to be approaching a number. Oftentimes it's 0. In this case, we can tell it's getting really, really close to 0, but never reaches it. Okay, and the word for that is asymptote, right down here. So our asymptote in this case would be y equals 0. Because your function never reaches 0, it's always going to be in the positive numbers. It's never going to be 0. It's never going to be negative. So your y values are always greater than 0, and that is your range.
Exponential. Whoop it goes. Exponential.
So what if we were asked to do the opposite? We're already given a table. Okay, first of all, I'm looking as x increases, y is also increasing. So again, this is going to be a growth. What is the y-intercept, or in other words, the a value? Well, I'm looking for the point where x is 0. Right there, so we already know the y-intercept is the point 0, 1. If you're looking for the a value, your a is going to be equal to 1. Okay, now the b value, of course, the rate that we're multiplying by over and over. So if we take a careful look at this, 1 times b equals 5. Well, I'd say that's 5. We're multiplying by 5 times 5 times 5. If you had trouble figuring that out, you can always find it by taking one value and dividing the one before it. So for example, we could get our b value 125 divided by 25, or 25 divided by 5. Okay, doesn't matter which of the two you take, but that is another method of getting the b value. So here we have, b equals 5. All right, we're looking for the asymptote. So paying particular attention to where x is negative, our fraction is getting smaller and smaller and smaller, but similar to what we said before, it's never going to be 0. So your asymptote is y equals 0. That also means your range, y greater than 0. Now the domain, this is not a word problem, so we're given no reason to think that the domain is restricted in any way, so we're just going to assume it's all real numbers. Okay, that's always going to be the case unless otherwise specified. Hope this helped.